In this tutorial, we'll show how to conduct a complete STPA, short for System Theoretic Process Analysis, using FASTEN. STPA is a hazard analysis method developed by Nancy Levison at MIT. STPA is based on system theory and examines how unsafe interactions and flawed control logic can lead to accidents. I'll demonstrate the STPA process on a highway pilot example, adapted from the ISO 21448 SOTIF standard. The first step is to define why we're doing the analysis. That means identifying unacceptable losses and the hazards that could lead to them. On the screen, I'm right-clicking in the model, choosing New FASTEN Route, navigating to Safety Models, STPA, and selecting Losses Catalog. Now, let's name the route node and add a few losses. Our goal is to protect the health of passengers and other traffic participants. Additionally, we would like to avoid any damage to objects. Lastly, we want to prevent customers from losing trust in our system. These losses help us understand what outcomes are unacceptable and guide the rest of the analysis. Next, I'm creating another route node for specifying hazards from the same STPA package. Hazards in STPA are defined as system states or conditions that, under worst-case environmental conditions, could lead to losses. Here are a couple of concrete examples. The first hazard addresses the violation of the safe distance to other vehicles. The second hazard expresses unclear control responsibility between the vehicle and the driver, which could lead to conflicting commands. I now link each hazard to the appropriate losses using the built-in traceability in FASTEN. Every hazard must be linked to at least one loss. In Step 2, we model the system's control structure. Here, we define the components involved in controlling the system and their interaction. First, I create a route node for the control structure. Then, using the diagram palette on the right side of the screen, I drag and drop controllers into the diagram area. I name the controllers and optionally include their description and responsibilities in the inspector. Next, I connect these controllers. To do that, I select a controller, and an option for connection creation will appear in the bottom right corner. Upon dragging the arrow to another controller, we are prompted if we want to create a control action or a feedback. I choose control action and specify them in the inspector. It is possible to have multiple of them for each connection. Similarly, I create a feedback connection from the vehicle platform to the highway pilot. This is the control structure that will form the basis for the rest of the analysis. In the third step, we identify unsafe control actions. These are situations where a control action becomes hazardous. First, I create a new route node and link it to the control structure we just built. STPA defines 4 categories of UCAs. In this tutorial, we'll stick to these, though FASTEN allows custom definitions too. Now, I specify the controller and control action I want to analyze. I select the highway pilot controller and analyze the brake control action. Let's analyze the providing case. I choose the textual description option, name it UCA1, and write a scenario with insufficient braking. This UCA leads to hazard 5H1, failure to maintain a safe distance. In a similar manner, I continue with the analysis for the remaining categories and enter the unsafe control actions in the table. The final step is identifying loss scenarios, situations that can cause the UCAs we just defined. Let's walk through one example. I add a new row, name the loss scenario, link it to an unsafe control action, and write a textual description. There are many approaches to loss scenario specification. In this demo, we utilize the one where we first specify an insufficiency condition and then describe causal factors causing it. This loss scenario is caused by incorrect feedback, which leads to the controller believing that there is no collision risk. An insufficiency condition possibly has multiple causal factors. First, the sensors can be physically corrupted, such as having an incorrect position or being occluded. Second, the feedback can arrive too late, or sensors may provide conflicting feedback, leading to the controller choosing the incorrect one. I presented the full STPA process in FASTEN. Each step builds on the last one, and FASTEN provides traceability and structured modeling to make the analysis both thorough and efficient.